All right, so real quick, before I started on the problems that I've been asked to go over, and then I'll open it up and we'll go over some more after that. I want to show you guys where the exam review key is, where you can find all of my worked out solutions. You want to go to modules. You want to scroll all the way to the very bottom of modules, and then you're going to click on today's date, December 13th. Scroll all the way to the bottom of the page. And at the very bottom, my complete worked out solution key in PDF. It is on yesterday's module as well, so you can find it in either place yesterday or today's module. All right, so jumping into these, you said 16 was the first one. For 16, we've been asked to go over. All right, problem number 16. Graph the solution of the system of inequality, state the coordinates of the vertices. All right, so 3 different colors for me. This guy right here, I'm going to change into slope-intercept form. Y equals negative 3x. Sorry, not equals, but inequality. Y is greater than negative 3x plus 2. So I'm going to graph that guy right here. But I am not going to shade him. I am going to put a couple little arrows so I know which way it would be shaded. But I'm going to wait till I get all of these up on my graph to actually do any shading, or else there's going to be too much going on. It's going to be too easy. So my first point would go right here, and then down 3, right 1, down 3, right 1. So I run out of room. Same thing in reverse. Dashed line for this, because it does not have the or equal to with it. And since it is a greater than, we want this guy to be shaded above. So I would shade it in this direction. Again, I'm not actually going to do the shading yet. I'm just going to write which direction it would be shaded. X is less than 2. I have a vertical line at 2 here. This one is going to be solid because it does have that or equal to with it. Since it's less than, it would be shaded in this direction. And then finally, we have this line up here or down here that I need to put into slope-intercept form. So negative 2y is greater than negative x minus 18. I'm going to divide everybody by negative 2. That's going to flip my inequality. So now that becomes a less than instead of a greater than 1/2 x plus 9. I'm going to be up here at positive 9. Do that really well. Anyway, 1/2. So up 1, right 2. I can't really go any further that way, but I can go backwards. And this is going to be dashed as well, because once again, we don't have the or equal to there. Y is less than means I'm going to be shading below. So this little triangle space right in here is where all of my shading would go. And this space right here is where it would be shaded. That is the solution to all 3 of them. The red line is shading this way, the purple line is shading that way, and the green line is shaded below. So the triple shaded region would be what I got colored in yellow there. State the coordinates of the vertices. Their numbers, their geometry. The vertices of a triangle are kind of like the corners of the triangle. So I want to name the ordered pairs where these 3 lines are intersecting. There's one that's happening at 210. There's one that's happening at 2, -4. And I've got two lines intersecting at -2, 8. And then 32 after that, right? $25 next. Marta bought a dress for the senior winter formal. She was bragging to her cousin that she only paid $68 total, including taxes for her dress. The sales tax in Indiana is 7%. What was the sticker price of the dress? So what was the before price tax? And we're assuming that this dress was not on sale. There's nothing else funky going on here. So the price of the dress times 0.07 will calculate just the tax. But then you still have to pay for the dress itself. And we know that in total it came out to be $68. So this is 0.07p. This is the price of the dress. How many p's is this? 1. So I can add those two together and have 1.07p equals 68. Then if I divide both sides by 1.07, I can find that the price of the dress before the tax was added onto it was $63.55. I would do part B the exact same way, but just with a different tax amount. So instead of 0.07, it would be 0.0625. And that one actually comes out to a same number for part B. Number 32, what's the next one that I've mapped for? That's okay. It's literally open. Right now it's like number 32. We can question on the home. Yes, you are allowed to use that. They have to be non-graphing, non-programmable calculators. So something like that pink one, totally fine. My yellow ones up here are totally fine. If anybody is taking AP stats at the same time, you cannot use the calculator for AP stats because they're graphing calculators. But as long as it functions similar to my yellow calculators, you're good to use that. And you may use that on the entire. All right. Can we do different does? It'll be alphabetical order. No, these. Let's read the table. Yeah, it'll still be the tables and we'll just be alphabetical order across the rows and then back. But yeah, that's gonna be the only thing. You guys come in. I will have the seating chart up on the board so that you know exactly which people you fall between and where to be. It is the one with pictures on it, so if you don't like it, I'm sorry. All right, number 32 has E parts to it. All right, we're supposed to write the expressions for each of the following and then state the domain. So first thing I want to do to this, because I don't want to write out something that's that long. I kind of want to factor that. What multiplies to 16 and adds to 8? 4 and 4. So this would be x plus 4 squared. So I'm going to write it like that moving forward. Plus that allows me to see what the domain for h of x is. And I need to know the domain for k of x and the domain for h of x on all of these. Because any domain restrictions that those carry, those will come with for A, B, C, and D. For part D, we'll have to look at something kind of a little bit different there, but we still need to know the domains of these two. Right? So if my denominator can factor to be x plus 4 quantity squared, what would the domain for h of x be? What's the only thing that x can't be? -4. X cannot be -4. What about with k of x? Square roots can't be what type of number? Negatives, can they be 0? All right, so all of my x's have to be greater than or equal to what? What would make it a 0 under that radical? 1/2. So I'll worry about writing things out in interval notation when I actually get to that part on A, B, C, D, and E. But just knowing what x has to be and what x cannot be is really, really important. Since on part A and on part B and C and D, I'm going to take both of these domain restrictions along with me. Do I have to worry about this domain restriction here? If I'm putting it together with this one over here? Why not? Yeah, you're absolutely right. -4 is already cut out over here. All of my x's have to be bigger than 1/2. -4 is not in that window. So this is going to be the most important domain restriction as I'm looking at parts A, B, C, and D. All right, so I'm supposed to add these two together. So the square root of 2x minus 1 plus -1 over x plus 4 squared. All I'm really going to be able to do here is get a common denominator. So I'm going to have the square root of 2x minus 1 times x plus 4 squared minus 1 over x plus 4 squared. The only thing I can do with this is to actually multiply out that binomial, which I already know what it multiplies out to, x squared plus 8x plus 16. But I'm not going to be able to combine it with that -1 because it's being multiplied to this square root here. So this is as simplified as I could make part A. So do we have to explain the x plus no? You could leave it either way. Since we can't actually combine it, I would take it either way. Domain though. Looking at what the domain restrictions are for either of these, so I know that we are 1/2 to infinity. Because if my x value is not at least 1/2, that would make what's underneath the radical imaginary. Part B is almost identical to this, except we end up with a +1. So that's the yep. You don't include anything for the for this part? Yeah. Well, I've already excluded that with this. If this was, say, x has to be greater than -5, then I would have to say from -5 to -4, from -4 to infinity. But because it's already left out of this window right here, I don't have to worry about the fact that it can't be -4, since this already says it can't be -4. That makes sense? Do you guys need to see part B, or are we okay with just the fact that it changes to a plus right back here? Okay. So I'm going to skip to part C then. We're supposed to multiply these two pieces together. So I have the square root 2x minus 1 times -1 over x plus 4 squared. Negative square root 2x minus 1 over x plus 4 squared. So I got a common denominator. This over 1, and I multiply top and bottom by x plus 4 quantity squared x plus 4 quantity squared. To get my common denominator. Does that make sense? That's how I got to the part that was exact. So. On part C, once I have it here and I need to find my domain, I see from the bottom that x cannot be -4. Up on the top, what can x not be? For the numerator on part C. 1/2, x can't be 1/2. So it doesn't make any sense for me to say so this does not make any sense with what I have written here, because this is excluding 2 different values. First of all, do I have to exclude 1/2? In this one, do I have to exclude 1/2? Is that left out, or can it be 1/2? If x is 1/2, what happens?
0.
I get a 0, so that is allowed. So since that would be allowed, that would mean something like this, but if I have a square bracket, I don't need to take those apart. Does that make sense? Plus, from my numerator, this is the only thing that works for my numerator. If x is any of these pieces back here, my numerator is invalid, my numerator is imaginary. So I don't need to worry about those pieces, because all of those would make my numerator imaginary, so I can get rid of that part. And so my domain would just be 1/2 to infinity. A lot of times when we see fractions like this, we're going to have all those different unions, but please make sure to pay attention to whether or not the union is necessary there. Yes, ma'am.
So is it like with common sense things, is it typically if those are radical and the numerator, the domain is going to be like the thing that makes the radical imaginary?
No, that is not going to be typical. Let me give you an example. Let's look at something similar, but not exactly the same. Let me make one up in my head real quick. Okay. All right, so if I had something like this, very similar to what we were just looking at, but just a little bit different. If I did, or that's okay, that's that. If I did f times h of x. Now this one right here, square root of x plus 7 times 1 over x plus 4 squared. When I multiply those together, I would have this square root of x plus 7 over x plus 4 squared. So there's my function. Tell me the things that x must or must not be. What about for f of x? Let's start there. Can't be anything smaller than -7, right? So -7 to infinity. What about for h of x? Can't be -4. So negative infinity to -4, union, -4 to infinity. Well, when I go to put those together, I can have things bigger than -7, but I can't have -4. So my domain here -7 to -4, union -4 to infinity. I'm kind of looking for where these things are overlapping on the number line, if that makes any sense. So if I draw just one number line here, and it has to work for both of these guys. There's -7, so anything here and over. For the one below. Anything this way or this way. So if I want something that works for the two of them together, I have to take this piece. Yes, ma'am. If you had the whole big long thing, yes, that would be incorrect. Because what you're saying is that X could be something like -10. And if X was -10 and you put it into that numerator, it would become that. So one of the ways that you guys can check, remember, you only have 20 questions on the exam. As you're going back and you're checking, say you're trying to figure out, do I have a correct domain? Pick out something in the intervals that you say would work and plug it in and see what happens. Make sure that those values really are working. Yes, ma'am.
So if there's like problem on the that we just if we're saying that the domain is 1/2 to infinity, so then my -1. Wait, so why didn't you use like before from the denominator?
All right, so look, we had to look for where these two things overlap with each other. Domain for each of these pieces. Well, when I look at these two right here, when I look at where those domains overlap, well, they overlap here, but I have to leave out that -4. -4 would be okay at the top, but it's not okay on the bottom. So I'm looking for things that work for both of them. So if I were to look at something similar to that for the problem that we just did, what was that on 32? All right. So for the top one, my domain is this, right? And for the bottom one, the domain is this. Correct? Well, where are they overlapping? Yeah, they're only overlapping for this part here. It has to work for both of them, so it has to be in the space that would overlap the domains for both of them. Does that help clarify?
Yeah, I was confused because I was like, well, put 0 + 4 and the denominator that's just 4. But if you put 0 in the numerator, it's value 1.
Yes. So we have to leave that one out.
Okay.
Does that make sense?
Yeah.
Okay. Is it helpful to see it drawn out?
Yes.
Good. Okay.
Wait,
Put a bracket on the -7 and not on the -4. Because if I put -7 in here for X, I would get a 0 under my radical, and I can do this fairly easy. So -7 would be an okay value here. And according to my bottom one, -7 is also an okay value there. Does that make more sense? Okay. You guys want to see the rest of 32 worked out? Okay. I'm hoping that it's making at least a little bit more sense now. So for most of these, my domain is going to be 1/2 to infinity because that's the space that's overlapping. If drawing that number line out helps, absolutely use that trick. Because it has to be the domains that are overlapping. Don't say that. All right, so on part D, since I'm dividing these, I would multiply by this reciprocal. Since that's my denominator, so I would end up with, I'm kind of taking a shortcut here, so don't be mad at me. Yes.
Is this final motion like I'm checking or more in the
What I can tell you about the final exam is that if it's on the final, it's on the review. But there's only 20 questions on the final, and there's not A, B, C, D, E, F, G parts. That is as much information as I can give you. What'd you say? One graph. The timer, you have lots of points. And then you have to connect one.
So the front face, I know it's the front.
You know,
I know it's the front. Yes, it's on here. That's what the front thing is. Right. Yeah, and then the one in the middle, it's on the video. It's, yes, I have 28 stars because I didn't. Yeah. Wait, so for D, it looks like.
Oh, that one. Yes, it does look like a front. It's like a, like, on the front face.
That's.
It's got this.
Why are those two pieces multiplied together and not divided?
Because, let me show you why.
Just put -1 in the numerator and then in the denominator, the x plus 4 squared.
So I would have the square root of 2x minus 1 divided by -1 over x plus 4
Never mind.
squared. And so then I'm gonna multiply by the reciprocal there. All right. E. By the way, this one has the exact same domain. A, B, C, D have the exact same domain because that's the same place that they're overlapping.
When you count points off, but you still left it over -1 for D.
If you left it like that,
No, like 2x minus 1 times x.
you get -1.
Divided by negative. Like square root of 2x minus 1 times x squared over on D.
On D, if you left it like that. Oh, if you left it like this, but a -1 on the bottom.
Yeah.
You wouldn't even fully simplify that. Now, is that gonna take it from many points? No. Another thing I will tell you guys about the final exam. Every single question on the final exam is worth the same number of points. They're all worth scared points.
Hey, but that means you didn't need to find it first.
They're all worth 4 points, so a total of 80 points on the entire exam. Will I do half points? Yes. If you miss something, I'm looking for overall mastery of concept. So if you make one tiny mistake in writing the final answer, but earlier in the problem, like you had it correct all the way to the end, you had it all the way to the final answer correct, and then you just wrote something down and circled it, like you dropped a negative with the right final answer. I'm probably, considering the fact that it's only 4 points for each question, I'm probably not gonna take off anything in that case. If it was a 10-point question, would I be for a half point? Yes, but do I think it's worth taking more than a whole % off over missing a negative that you had the whole time up until there? I'm not gonna do that. I'm trying to keep my eyes on how much is it actually impacting your final grade when I take off a half point. Would I even consider quarter points? I normally hate doing quarter points, but would I consider that on the final exam? So I will take it all the way to the beat. If you end up with a 0.5 or higher, I'll have it up to next year. Yeah, I don't want to do decimal percentages on the final. All right. Part E. This is a composition of functions. This is not multiplication. We have this open dot in between them. What this notation is telling me is that I have K with H inside it. And so I have k with h inside it here. And so then I'm gonna write down my function k, and I'm gonna take this right here and put it in the place of the x. So I would have the square root of 2 times all that junk. -1 over x plus 4 quantity squared. -1. I'm gonna multiply and I'm gonna get a common denominator here. So I would have -2 x plus 4 squared minus x plus 4 squared over x plus 4 squared with a big square root around the whole thing. Then I have -2 minus x squared minus 8x minus 16 all over x plus 4 squared and all underneath this square root. So negative x squared minus 8x, sorry, I did that for squared on that one. Minus 18 over x plus 4 quantity squared, all underneath my square root. The -2 came from right here, that came from multiplying my numerator, right here. And then I multiplied that out and I distributed my negative here. So that would be x squared plus 8x plus 16, but then I have to distribute a negative to all those pieces. So this is what it is when I compose them together. And the domain of this is actually empty. There are no real values that make this work. So domain does not exist.
So do you want us to break down the x plus 4 squared
On the bottom,
on the top? Like if we did negative x minus 4 squared with the 2 outside of it?
the only reason that I wouldn't do that necessarily, although you could, is you want to know where this thing lies. Because the whole reason that this domain does not exist in the real plane has to do with there is no value of x that I could put in here where it touches the x-axis. So all of it would actually end up being in a space where underneath my radical, I'm going to have a negative. There's nothing I can put in for x to save that. Domain for D is going to be the same as the domain here, because that's where they're overlapping together. This one's the only one that's a function. When you take one function and you plug it into the other function, that's when you're not just looking for the overlap. If you're adding, subtracting, multiplying, and dividing, you're just looking for where they're overlapping. You do have to usually pay a little bit of special attention here, because if you put something on the bottom that wouldn't normally, like say it was just a linear function, and now all of a sudden it's on the bottom of a fraction, you have to add an additional restriction. Not necessarily. This one there wasn't. Let me give you another example where we could have a domain that works. If I had say f of x, 2x minus 5, h of x is x squared plus 2. If I did f of h x, so I will have f of x squared plus 2 So 2 times x squared plus 2 minus 5. So that would be 2x squared plus 4 minus 5. 2x squared minus 1 is what I would get when I compose those together. And then I'm looking at, are there any restrictions here? No, this one, my domain is all reals. This one, my domain is all reals, right? When I put them together, when I compose them together, because this one had no restrictions and this one had no restrictions, when I compose them together, this guy has no restrictions. So this one would be a domain of all real numbers. So what I'm looking at is there anything that breaks this one? If there's anything that breaks this one, can't include that. Have to leave that out. And if that, like, whatever that output would have been, if I couldn't have done that, I can't feed that in as input. Does that help a little bit?
You have restrictions.
Yes and no, you have to really look for, like, am I gonna give you something, did I do you something on the exam where you have to really like, but what about this, what about that, I would have wanted to do.
So they're going to be more like those.
It would be more like this or like this.
Okay.
Are you looking for where they're overlapping? What works for both of them? Or a case like this one where you'd be able to easily say, oh, well, like if that was square root of x, well, x can't be anything smaller than 0. So then I would have to carry that restriction with me into this one, even though it might not. Let me look at another example. What time is it? Okay. If we can use questions and absolutely, I'll do my absolute best. All right, so something like this. If I compose these together, this one does not have any restrictions. But in this one, 0 to infinity, right? So if I compose these two functions together, I'm gonna have 2 square root of x squared. So this actually just comes out to be 2x. If I look at just that, I'm like, oh, well, there's no restrictions there. But there is, if I'm not allowed to feed anything into it that's smaller than 0. Does that make sense? So this one would have restrictions on it. This one, my domain would be 0. Even though the linear function by itself doesn't look like it has restrictions because it's made up of something that does have a restriction on it. I have to keep that in mind and carry that with me as I compose it.
I'm considering taking the final today. Taking her final.
What about
Sorry. I'm teaching all day long.